Yeah, yesterday we talked about a lot of things. We talked about expressions, how expressions is being used. If else expression we talked about, how if and else can return a value. Similarly, we talked about match expression. Match expression is also able to return some value. Then we saw match expression with default data types. Sorry, not default data types, basic data types. Then we also saw that match expression with with wildcard patterns. In wildcard patterns, we saw about value binding was one thing. Along with value binding, we saw pattern guard so that we can have a if condition along with the value binding. Then we also saw underscores, which is nothing but the default case. So we just saw the basic way of using a match expression. Then we saw one of the use case of the match expression where we want to dynamically know the data type, and based on the data type some expression I want to evaluate. So such kind of a thing if you want to do, match expression comes in very handy. Then we saw the uh, for expression. Then we saw the for expression. I said that for expression will also return some value. For can be used for mutability purpose. For can be used for immutability purpose. It can be used for mutability and immutability. In most of the traditional things, I think from from software point of view, whenever we wrote a for loop, most of the times we used it for mutability purpose. We tried to modify something, we tried to aggregate something, we tried to calculate a sum, total sum, or modify an array, anything. But now we will also see how it is used as an immutability, and also we'll see what is the use case of having such an immutability. So yesterday we saw simple loops. Yesterday we saw simple loops with the a new syntax that is associated with the for loop. For loop older syntax or the existing traditional syntax doesn't work here. We have to use some other syntax. So we saw just few examples, like I can say for I 1 to 7, then I can say print ln. I can also exclude the last one by just specifying until 7. By just specifying until 7. In a similar fashion, if I want to iterate, by default it gets iterated by incrementing 1. So I can specify different delta as well. So if I want to specify different delta, I just say by 2. If I want to reverse it, if I don't want to start from 1 to 7, I want to decrement it from 7 to 1. So if I give such a thing, nothing works. If I give such a thing, nothing will work. So in that case, what I have to do is I have to just say -1. Decrement by -1, then it starts working. So this is what we saw yesterday as well. A simple for loop, how to loop through a for expression with the numerical data types. The only criteria I said that this should be an identifier and this should be a collection or an iterator. 7 to 1 is nothing but a collection here. It is internally represented as a collection. And we also saw that what for loop returns or for expression returns. When I say val x equal to this, we know that in this case for did not return anything. For did not return anything, hence the return data type is unit. The body of the for expression was just a print statement, and print statement returns unit, hence its return type was the print ln's return type was unit, hence the x return type is unit, hence data type is unit. Now how do I this is the basic thing. I can just normally I can just go in this fashion where I can say sum is equal to, this is the basic thing that we do with the for expression. So this is the basic thing that we do with the for expression. We did not return anything from here. We did not return anything from here from the for expression, but we modified a global identifier. Now we can check the value of sum. This is how we usually use a for loop. This is usually how we use a for loop. Next we'll see what we can return from the for loop. What we can return from the for loop. So to make it return from the for loop, we use the same syntax plus a bit additional thing. For immutability purpose, the way we write is for, we have an expression here, then we have a yield keyword, then our body. This is our body, or I can say block of expression. This is usually the for expression. Then we have the yield keyword. This is used to, this makes for to return some value. Return value after evaluating the body of the expression. What value will be returned? The value will be returned whatever is in the block. We know how a block works. We have already seen a block of expression. Whatever you write, after evaluating that, whatever value we get, that value will be returned from the for expression. The same thing holds good for also. The only thing is we have to have a yield keyword here. That's how it makes it as a. So let's use a for loop. I will say the same expression I will say, and I will say val x equal to something. That's the reason we are able to use the equal to sign before the for expression. I will say 1 to 7. I will say 1 to 7 here. Even though block parent flower brackets are not required, because I will be writing only one expression. I will use a string interpolation. I will use a string interpolation. I will say day colon dollar symbol I. I gets evaluated. We know that whatever is inside the I dollar symbol, that gets evaluated if we prefix the string with yes. That's what we call as a string interpolation. Now what is the body of this for? Okay, I did not do anything. I did not use the yield keyword. If you see here, I did not use the yield keyword, hence nothing was returned. Even though we had this as the last expression, nothing was returned because yield keyword was not used. So I will use the yield keyword, and this time a value will be returned. And what value will be returned? It will evaluate the body or the block of expression this. Whatever value we get, that value will be returned. So what value we get here? For I is equal to 1, we get day 1. For I is equal to 2, we get day 2 as the string. The string gets evaluated and that string is returned. So finally what we will get? For every loop, one or the other, day 1, day 2 will get. So how it will return and store it in a X. So since we are returning multiple values for each value of I, so it will be collected in a collection. It will be collected in a collection, and finally the whole collection is returned from the for expression. So this time if you see, for I is equal to 1, it was day 1. For I is equal to 2, it is day 2. For I is equal to 3, day 3, and similarly for I is equal to 7, day 7. It evaluated everything that was there in the body of the for expression. Whatever value it got, that value was stored in a collection, and at the end of the loop, the whole collection was returned. Whole collection was returned. So that's the for loop. For I usually say that's the for expression which is returning some value. X, if you see, it is a collection actually. It is an indexed collection. Yeah, it is X is mutable. X is mutable, but the collection is still immutable. Here is a question. The question is if we specify this as var, then whether it is a mutable. Yes, in that case, X will be mutable. X will be mutable, but this collection will still be immutable. You cannot modify the contents of the collection. But for X, we can assign some other collection also, if we make it as var. Now, what we have seen now, as of now, what we have seen, we have a for expression. So let me put it in this fashion. We had 1, 2, 3. I will not write everything. So we had this collection. So 1 was transformed to day 1, 2 to day 2, 3 to day 3, 4 to day 4. So if you see, there is a one-to-one mapping that is happening. So if you remember from your set theory, mathematics set theory you might have learned. So we see that there is from one set to another set, there is a one-to-one mapping based on f of x, based on the function that you define. If you say f of x is equal to something, f of x we say usually as, here f of x is nothing but $i. So it is nothing but, what I'm trying to say is the body of the for expression. So based on the body of the for expression, each element of the source collection is transformed to some other element in the destination collection, based on what logic we specify inside the for expression. So that's the use of for as a immutability. Whenever we want to do any kind of a ETL, anytime we want to do some kind of a transformation, for with mutability is usually used. Sorry, for with immutability. Any transformation. Let's say in a database you have 5 columns. In a database you have 5 columns there. So out of that 5 columns, you want to pick up only 3 columns. So what you will do, you will say select A, B and C. Let's say that columns are A, B and C. You will just say select A, B and C. When we say select A, B and C, every row will be picked up and only A, B and C will be taken into. We are transforming that data table into some other table. When we say a select A, B, C, we are transforming the data. Every row is being transferred. Every row is being transformed. It takes each row and transforms into a 3-column row. It takes a 5 column row and transforms into, that's what I'm trying to say here. Any kind of ETL we want to do on a collection where you want to process every element of that collection into something else, we use a for expression. We use a for expression. For expression meaning for as a mutability thing here. So I hope that was clear. I hope that was clear. So internally what happens here is, internally for yield we are using, right? This is internally implemented using a function called map function. Internally it is implemented using a map function. So most of the time we may not use the for with yield. Most of the time this is used. And we will look into these functions as well. Going forward we will look into this. But this is how we say that it is a for with yield. It is used for a transformation. Used for any logic you can specify. You can specify any logic here and you will get, based on that logic we get a different collection. If you see uh, initial collection was an integer. It was a collection of integer, we got a collection of string. So we transformed our data. We can do any kind of transformation based on what logic we specify. So I hope that was clear. Any questions here? So if there are no questions, we will move on with the next part in the for expression. So we have seen iterator, we have seen matching guard, pattern guard. If you remember, a pattern guard is just a if condition. In the match expression, we saw pattern guard providing a if condition with the value binding. In a similar fashion, in the for expression also we call it as a iterator guard. When we say iterator guard, there is a if condition here, so that we can filter out some records. We can filter out some records. So I can use such a thing. So if you see here, I'm iterating from 1 to 10, and as we see that it is an iterator guard which is one expression, hence we don't use the semicolon in between. Even if you remember, in the match expression, we specified the value binding and the iterator guard. We never had a semicolon in between because both are taken as one expression. So it will iterate from 1 to 20 and it will check whether I is divisible by 3. If at all it is divisible by 3, that value will only be yielded. Otherwise, it will not be yielded. So we will get it will return a collection of multiples of 3. It will iterate or I will say it will return a collection of multiples of 3. So if you can clearly see here that we have filtered out certain values. We have filtered out certain values. We had 1, 2, 3, 4, 5, 6. I will not write all the things here. Out of this, we got only 3 and 6. So destination collection was only this. Our source collection was this. And what we are doing is we are filtering out something here. We have mapped this to this set, meaning we have filtered out. So for yield and iterator guard is used whenever you want to do such some kind of a error handling. You have a data set with hundreds of records or thousands of records. Out of those records, I want to filter out certain records which are not good. So that logic you can specify in your for expression. And certain fields or certain records will be discarded. Only whatever record we want, that record we can use. So that's the use of for, yield, and iterator guard. And internally, as for yield is internally implemented with the map function, for yield and iterator guard is internally implemented using a filter function. And most of the time we use the filter function. We will be seeing filter function as well. Filter function as well. So everything is transformed into a function so that it could return some value. Yeah, here is a question. Here is a question. Is in the backend two collections are created in case of filter? Even for both the cases, there are two collections. Okay, okay, not two collections, only one collection. The source collection and the destination collections, if you are talking about then two, then that are the two collections, source collection and destination collection. And it holds good for the for and yield also, not just for the filter part, also for the mapping also. Two collections will be there, source collection and destination collection, because we said that collection is immutable. We are trying to transform elements, hence one more collection gets created. The same thing holds true here. I hope that was clear. Yeah. Yes, we can. The source collection, actually when I say, I can just say val r equal to 1 to 7. When I say 1 to 7, actually it returns a collection. It is called a range collection. This is one collection actually. So whenever we use, as I said, the right hand side of this should be a collection or an iterator, and 1 to 20 is actually an iterator or a collection. So I hope that was clear. So as I said, on the right hand side there has to be a collection. It need not be a numeric collection. Range collection comes as a handy. Range collection comes as a handy if you want to deal with numerical values in the for loop. If you want to deal with numerical values in the for loop, range as a collection makes a bit easy things. It makes easy, or you can say it comes as a handy. But if you want to use some other data types in a collection, I can do anything. I can say val array is equal to, I can say, a list. This is how we create a list, or I will say initially we'll take array. I can say so I can also loop through this. I can say for anything SA. As I said, on the right hand side it should be a collection which will loop through each element of the collection, and I can just say anything. I will just say this is a mutability thing. This is a mutability thing. Now what I want to do is I want to, let's assume I want to get the first character of each element. How can I do that? Here is a question. The question is, if I want to get the first element of each, sorry, first character of each element in the array, first element, first character of each element in the array, how can I do that? Any guess on that? So if I put in a graphical manner, probably, uh, somebody asked a question, how to access the value from val 3 variable from outside of the, yeah, we will see that. As it is a collection, we will see that. So 3 is a collection, right? If you see 3 is a collection. If you see 3 is a collection, we just say 0th index will give the first element, first index will give the, this is how we specify the index. So this is how we access. So I hope that was clear. So what I'm trying to ask the question here is, I have a collection or an array with Scala, then I have Java, then I have Python. So when I have such a thing, I want to transform into S, J, and P. I want to get these things from here. So how can I do that? So it is all about returning one more collection with these after doing a transformation. So obviously we need to use a for and yield. So this is where we use the for yield. So we take a collection, transform into whatever things we want, then give the value of that collection. So how can I do that? So I can say val something C for, I take each element, I take each element of the, what did I define it as? SA string array. Then I will say yield. We know that C is each string, sorry, S is each string from the collection. I have to just say S of 0. S is a string. String is nothing but a collection of characters. S is a string and string is nothing but a collection of characters. If you want to access the first character of the string, we just say S of C. So we can see based on what logic you give here in your body of for expression, a transformation happens. The transformation happens. Now I want, let's say I want, probably these could have taken as like exercises, but that's fine. So I want the length of each string. So this, I want a collection which gives 5 here, 4 here, and 6 here. I want the length of each string. So I can use my for loop again, and I can just say string has a method called length. I can just use that. I can just use that. So we are doing a transformation. We are doing a transformation here. So I hope these things were clear. Why, when to use the for expression with the yield. Whenever we want to transform your collection from one form to another form, we use a for expression, for with the yield. And most of the time we don't go with this. There is an internal API already available which is mostly used, that is a map function. The name itself says map. Map each element from the source to some other source. Even in map reduce also it's the same concept. If most of the people are a background from map produce, if people have gone through map reduce, what does map do? Map function, what does it do? It takes key and value, and it based on some logic here, it outputs some other key, let's say key X, and some other value. So if you take the whole thing, from each record it takes this whole thing and transforms into some other key value. For each record it does, for each record. So that the whole thing we are achieving, this is done in MapReduce framework. This is done in MapReduce framework, and we are able to see this being done in the Scala language itself. This is being done in the Scala language itself because for expression returns a value. Because for expression is able to return a value. So I hope things are getting clear here. Yeah, whenever we want to do the transformation, such kind of a transformation, we use for with immutability. Whenever we want to do such kind of a transformation, we use for with immutability. For with mutability is our age-old whatever we used to do. For with mutability is whenever we want to compute sum. We saw that age-old things. Sum is equal to 0. We can say, I can say for I 1 to 10, then I can say sum plus equal to I. Such kind of age-old things, whatever we used to do earlier. So that's where we use the for with mutability. Sorry. So now you can see that we have modified the identifier sum. That's the difference. That's the difference. So here also the if condition, if you, I hope Rajshekar that was clear. Again we can write for expression in this fashion. If you are giving, we can give it in the multi-line also. We can give it in the multi-line also. If you are having more than one expression and writing it in a multi-line, we can use a for loop with the flower brackets as well. So as I said, on the right hand side of this arrow mark, should be a collection. So this the quote is actually, if you see, quote is actually a string. But I said that it has to be, a string is also a collection, but the split will always give you an array. Split will always give an array. So this becomes an array. On that array, we are checking whether each element is not null, and also if the size of each element is greater than 2. Only those elements will be returned from the, not returned because we are not using the yield here. We are just doing the print. So this also is the one more way of writing the program. So one thing to be noted here, I forgot to say that with the filter. So if you see here, we had this iterator guard, and we got a collection which is divisible by 3. Now I will just modify this. I will remove the iterator guard here. I will remove the iterator guard, and I will put that logic inside the body of the for loop. I will say if I percentage 3 is equal to 0, then return I. So now what will be the collection here? What will be the return collection? In this case, sorry, minus. So if you see in this case, when we yielded I, we got this collection. Now what the for loop will return in this case? Does it return the same thing, or does it return something else? It's not an array. It will be still a vector. Vector is a collection. But my question was, my question was whether the content of the collection will be same numbers, or the something else will also be there. Whether it will contain only the divisibles of 3, or something else will also be there. Yeah, it looks to be the same. It looks to be the same. But if you remember, this is not iterator guard. This is a if-else expression. This is a if-else expression. Only if you specify it inside the for expression itself, only if you specify a if here, then it is the iterator guard. I said that iterator guard is different from if-else expression. So this is a if-else expression. We know that if the condition is true, it returns some value. If the condition is false, it returns some other value. We have seen that as a if-else, and compiler considers both if and else, even though you give only the if condition. So when the condition is true, it will return this, and if the condition is false, nothing is there to us. Hence the return type is unit, and unit value is represented as parenthesis. So it will be a collection of these numbers plus parentheses. It will be a collection of these numbers and parentheses. So we have to be a bit careful. So whenever we use the if expression in the body of the for loop. So you may end up giving such things. So to avoid such a thing, right? To avoid such a thing, we have, as I said, internally for expression is in for with yield. To avoid such a thing, we are getting such a thing because instead of iterator guard, we use the if condition inside the body of the for loop. So, but there are most of the cases will be such type of cases. We might have to write a if condition. We might have to write the if condition. So, how do we get rid of such a return value? So we can get rid of, as I said, internally it is implemented with the filter function. Most of the time we write a filter function. Most of the time we write a filter function. So we'll see that. Once we learn about map function or filter function, it will be much easier. But I hope the logic was clear here. Why did we get these things? Why did we get these things? These are all unit is represented in this fashion. Yeah, nested loop. We know that if you want to write a nested for loop for I is equal to 0, usually we write in that fashion, right? Usually we write something like this. And then we do some logic here. So this is how we write a nested for loops. But we can write the same thing in a much simpler fashion in our Scala. We'll see that. So here is the question: if we use conditional statement by default in a if we use conditional statements, no in a no, I didn't get the question, Rajsekhar.
Sorry, Pramod, right? In the previous segments, we used for and flower bracket and couple of statements, right? T is not
Uh,
equal to null and T.
your voice is breaking. I mean, I could hardly.
Yeah, the previous, right? In the for loop, right?
Yes.
You wrote some conditional statements. The for loop, like T is greater than not that filter conditions. In
Oh,
the
okay.
documents, you showed something.
Right, right, right.
We
Yes.
see the and by default conditionally by default that is and conditionally default, right?
Yes, yes. It is and actually. This also should hold good, and this also should hold good.
The and condition, right?
Yes, yes.
But what about R? If you want to specify R,
Or also, 1 second. Yeah. I haven't tried these things because most of the time I use the filter higher order function. Let's check what it does actually. We usually don't use this. We can use in this fashion. Oh, 1 second. Value is t is not a number of unit. If t is not equal to null, t is not a. Let me check what is that error. There is a strange error.
No problem.
I will just check that what is that error and send the result.
Sure, sure.
Yeah, what happens here is I usually don't use this. Most of the time, as I said, internally it is represented using the filter function. I always write a filter function. It becomes a bit easy in the filter function. We don't have to, we can specify any logic there. Here it becomes a bit restricted thing. So I will, but still I will check how it can be done, and I will, but by the end of the day I should be able to do that. I will be sending the code. Yeah, let's move ahead. As we are as I said, for nested for expression, we can write the whole nested for expression in this fashion also. We used to write in this fashion in the traditional programming language. A for inside the for, the same thing could be achieved with this. The same thing could be achieved by this. We iterate from 1 to 2, then for each value of x, we iterate from 1 to 3. And finally, we are just printing here, we should have the value 3. So that's how we use the for expression for multiple loops. In a similar fashion, please do try that as well. Similarly, we have a value binding. We saw in the match expression also, we saw a value binding. Here also we have a value binding, meaning we bind the value here itself. We can do something like this here itself. I am just incrementing it by 1. Just incrementing it by 1. I take each element from this collection from 0 to 8, and the logic that I am giving here itself means this identifier increment is value binded. Whatever value we get from this, it will be binded to increment identifier. And finally, that will be collected in a collection, and the collection will be returned because we are using a yield here. We are using a yield. So that's what we call as a value binding. We can do it in the body also. We can do it in the body as well. So it returns, increments the value by 1 and gives the result. So I can write the whole thing in the body of the for expression also. So I mean, I can remove this value binding. Any simple things you want to do, you can put it in the uh, for expression. Any lot of code you have to write, you have to put it in the body of the for expression. So here I have to define val increment is equal to I plus 1. I have to define it as a val or var. But here I need not. Here I need not. I have to just. Then we know that if the if the block of expression contains only assignment as the last expression, nothing will be returned. Nothing will be returned. So we have to specify that as the last expression. Only then that value of that identifier will be returned. If you only have the assignment, nothing will be returned in that case. Then it will have a vector of parentheses. So this is how we can achieve these things can be achieved in the body of the for loop by doing such a thing. So what happens if I The scope is within that loop. The scope is within that block. The question is, what is the scope of INC? What is the scope of INC? The scope of INC is inside this block. So what happens? What happens if I have the same thing and I assign this and give this? So we know that this is the last expression in a block of expression. This is the last expression in the block of expression. Hence, it is just an assignment. Nothing is returned from this. Hence, the return data type will be unit. So it will have a collection of parentheses. So it will just have a collection of parentheses. Unit, for every element a unit was the return data type. So that's the reason it will have in this. I think something is similar to the logic what I have specified in the OR. There is some logic similar to that. I think here also we are getting error, right? There is something like there is something returned which is not supposed to be returned. That's the error. I will just check that also and I will let you know. But I hope the value binding was clear here. We can do the value binding here itself, or we can do in the for expression itself. I mean to say, sorry, or we can do it in the body of the for expression, but we have to be a bit careful that we have to put as the last expression so that it gets returned. Otherwise, we only have a assignment in the body of the for expression. Nothing, nothing gets returned. Hence, it will give a collection of parentheses. So that's the for expression from the Scala. It's slightly different from the normal traditional for. That's the reason I took it. Whatever were the new things, I took it here. The old things we did not talk about. But the old things also work for the mutability purpose. Next we have the while loops. I will not discuss anything about the while loops because it is same as in other programming language. We use it for mutability purpose. We use it for mutability purpose. If you see the generic, the body is usually a statement. Statement means no return value. No return value means mutability purpose. So any aggregate.
Pramod, hello Pramod.
Yeah, Srividya.
I have a doubt here.
Yeah.
When we are using yield, then every time we are executing the body of the for loop,
When we are using,
uh,
can you repeat that? Your voice is a bit low.
when we are using yield, every time we are looping through the body of the for loop, do we assign this INC value to the increment every time we loop through the for loop, or at the end of the for loop, the final value of INC will be returned to increment?
Every time. Every time an object will be created and it will be stored in a collection. So this return internally will be stored inside a collection.
So every time we get a value in INC, the same time we get the value in the increment, right?
Every time we get the INC value, it will be stored inside a collection. I'm not sure
That
whether we are on the same page. Can you repeat the question, because some words are
here
getting.
we are, okay, I will repeat. See, here we are. we have val inc is equal to I plus 1.
Correct. Yeah.
So here we are passing that value to the inc collection, right?
Yes, it will be collected inside a collection. A temporary collection will be created.
Yes. So
At the
at the same time the value is passed to the increment, val increment.
at the same time, in the sense, no, I didn't get that.
Like here we are returning inc to increment, right?
No, no, this we are not returning to this. This when we say return, this itself is making it to be collected in a temporary collection.
Oh,
We have the new value. I was 0. Then we said I increment become 1 now. That 1 we want to store it in a temporary collection. Only it happens because of this last expression.
okay,
So whenever we specify this last expression, meaning we are returning from the for, and where it will be returned, it will be returned inside the temporary collection. And finally at
okay,
the end of the loop, the temporary collection will be returned and it will be assigned to this.
okay. That's clear.
Yeah.
That's what.
Okay.
Thank you.
And those things will be internally taken care by the Scala language. So while loop will just ignore the while loop. We'll start with the functions here. We'll start with simple functions. How a function definition. I think most of these things are as of now bit. The function will start with the basic things. How to define a function. I may not go with the documents here. Probably I may skip something which are more simple here. So the way we define a function is we use the def keyword. Def, I can say, give a name to that function, product, pass the parameters as this. We know that we need to specify the data type in this fashion. Data type always comes at the last. So then an equal to sign will be there. An equal to sign is used to separate the name and parameters of the function and the body of the function. The body of the function is just I am saying x multiplied by y. So this is how we define a function or a method in this syntax. An equal to sign is there, meaning here that it is trying to return some value. It is trying to return some value. So you can see that the return data type was automatically inferred by the compiler. We didn't have to do anything here. Based on what is the last expression of the body of the function, so the return type was automatically inferred. Since it is a x star y, which is a multiplication of two integers, the return type is also an integer. And this is the as traditional way of calling a function. That's right. This is how we traditionally call function. Usually we don't write an independent function. We usually put it inside a class. We put it inside a class here. When we develop any project, there will be no independent functions, but everything will be a part of a class here. We will see those things as well as we go and write some programs, some IntelliJ, or when we will be discussing a Spark application. So there are some other basic types as well. Probably it can be checked. So we can have a function like this. I can define a function saying hello. I can define a function like this without any parameters, then the body of the function is nothing but this. This is the body of the function. This function doesn't take any parameters, but it returns a string. Hence the return data type is a string. So I can call this function with parenthesis, and also I can call this function without parenthesis also. So you can see some of the code being written. If they are not using any parentheses, the function can be called in this fashion as well. So these are all just basic types, just to remember that you don't come across any errors. Yeah, again there are some jargons. There are some jargons, and these jargons are again associated with mutability and immutability. Meaning, we know what is an expression. Expression means return value. We have seen statement. Statements means again no return value. In a similar fashion, we have functions here. Function, just a jargon, which means return some value. The function returns a value. They say it as a procedure, which does not know return value. So finally, if you see, both the things boil down to mutability and immutability. And this is nothing but mutability. So you have to just don't need to go into the jargons. It's all about mutability and immutability. So if you have a function which does not return any value, it is called as a procedure. We usually use it to do some mutability things. So we can define a function, say log, and I can say I can write a print here. Sorry for that. So this is you can say it as a procedure, because we are not returning anything. Automatically it has inferred it as an unique data type. We are just printing the content. We are modifying the console. That's the mutability we are achieving. So this is called as a procedure. That's all. A function where we do mutability is called a procedure. So I have to just say log of any string I can. So this is a mutability. I mean to say a procedure. So I hope that's the difference between functions and procedures. Functions and procedures. Functions with empty parentheses we saw. If we define a function like this, we can call that function with the parentheses. We can call that functions without parentheses also. Without parentheses also. Now there is one more function. Let's say I am defining a function called a simple function. I'm defining a function format euro. It takes some double value and it does some formatting here. We know that F is used for formatting. F is used for formatting. It is doing some string formatting, that's all. And it returns that value. That value is being returned. Now I can call this function. This is a traditional way of calling the function. This is a traditional way of calling the function. We can also call this function as a block of expression, meaning I can pass a block of expression here. I can say val rate equal to comma, we can say rate plus. So this is a block of expression. This is a block of expression. This block of expression gets evaluated. After evaluating this block of expression, whatever value we get, that value will be returned from the block of expression and it will be passed as a parameter in this fashion to the format euro. It will be, the return value will be passed as a parameter to the format euro. So we can call a function with the block of expression also. We can call this the block of expression. So what? So I can write anything. So in that fashion, let's say I have now val rate 1 is equal to 5.6. So now what will be the, what it will do? Now what will be the input to the format euro? Any guess on what will be the input to the format euro? Not null. So if you take this expression, if you see this block of expression, I will just take this block of expression. So I will just say val x equal to that block of expression. Val x equal to, we know that what does it mean? If you see the last expression, is just an assignment. If the last expression is just an assignment, what will be returned from this block of expression? Unit, nothing will be returned. Hence the return data type will be unit. So we are trying to pass whatever is the return from this expression. We have defined our format euro to accept double, but we are trying to pass unit to that. So it will give an error. So if I put the, so you can see that required was double because it is a double, but we are sending unit. Hence the error type mismatch. Error type. Yeah, here is a question. Is null and nothing different here? Yeah, it's a bit confusing even for me, but they are different. They are different. I tried to go through this, but never came across as a programming language. In the programming language and when developing any application, I never encountered this. But there is a bit tricky, but they are different. Null is different, nothing is different. All are class here, but it's a bit confusing. Even I am a bit confused on that if I see the hierarchy. So the question was is null and nothing different? But I can, again, I will try to go through as much as possible. If I get an answer, surely I will let you know. So if you see here, nothing is a class. Nothing is a subclass of null class. Null is actually a class. We can create an object of the null class. And nothing is also, but I need to still go into more depth why such a thing was done. So once I get clear on that, why such a thing was done, what is the use case of null and nothing, I will surely let you know. I tried to understand it, but still some confusion is there. I will let you know. But they are different. One is the subclass of the other. So that's the block of expression. Uh, in case of for loop, no, we already saw that, Rajshekar. I will just send you a mail. I will send you a mail with the both two different examples. So recursive functions may not be required, very less. It's the same as the same other functions. We call the functions from within the function itself. That's what we call as a recursive function. And probably we don't need such a thing, but if you have any questions or doubts, we can clear on that. Of course, a function being called within the function itself, it's the same traditional thing. You don't have to go into that. If you face any problem, just let me know. Similarly, nested function. Nested function is nothing but defining a function within a function. We usually don't define a function within a function. We can define a function within a function. So that scope of that function is only inside that function, inside the outer function. So, but again, it's something kind of the private members of a class, similar to that. So we can define function 1, some x as the input, something. And we can define one more function here. Define function 2 which takes y something. We just say y start with something. And this function can be called only inside the function 1. Function 2 can only be called only. I can do some val y is equal to x plus 10. Then I call function 2 with y as the something. So the scope of this function, f2 is only inside function 1. It is not inside. You cannot call it outside the function 1. That makes it to be a private. Yeah, these things are not required. Calling functions with named parameters. These are all simple kinds of functions. You can also go through that. Here it's nothing but we have a simple function. We call that function in this fashion. We can also call that function in this fashion. You explicitly use the suffix parameter and assign a value. You explicitly use the prefix parameter name and name the value. So these are all normal things. We don't have to care more about these things. With default values also we know that. We can have a default value. While defining a function itself, we provide a default value. But we can override it later also. Default values as it works in other programming language, here also it is the same thing. Here also it's the same. And here we have the variable number of arguments. you can pass variable number of arguments to this function. The star is used for that purpose. Star is used for that purpose. So Rajshekhar, you can consider this to be a mutability for expression. I think there is, yeah, there was a voice disconnection. So what I was trying to say here is, Rajshekhar, you can consider this to be a mutability for expression. Along with that, the concept here is variable number of arguments. We have to just assign a star at the end of the data type. So this function, if I define, I can just call this function without any parameters because it is a variable number of arguments. 0 or more number of arguments. I can call this as this. I can call this as this. I can call with any number of arguments. Any number of arguments. So that's how you define a variable number of arguments. So I hope these were all simple things. There is one more new thing that is associated with Scala is the parametric group. A new thing associated with the parametric group. What is that new thing here? So I can define a function called product. I can define a function called product, and I will say x is int, y is also int, some two parameters I am passing. Then I will say x star y. This is my function, simple function that takes two parameters and multiplies both the parameters. That's the traditional way of defining a function. Traditional way of calling a function is 4, 5. As simple as that. But we can also define a function in a slightly different manner. So that we call as a parametric group. We call it as a parametric group. I can call. So this is one parametric group. This is one more parametric group. So there is no new concept with parametric group. The concept, nothing is there. It is only the syntax. So these syntax are used in higher order functions, and they are used in implicit functions. We will be looking those things. Till now you have to just hold back on this thought. And I just want to clear one thing is there is no new concept associated with the parametric group. It is only the syntax. And these syntax will be using in the higher order functions and implicit functions, which we are yet to see. Those are all some complex things. Once we learn those things, the parametric group syntax will also be clear. If you see, the way we call this function is 4, 5 something in this fashion. The logic remains the same, only the syntax has changed, and that syntax is called parametric group syntax. So we can have any number of parameters in each group. I can say int x, or I will say x, y as int, and I will say a as int, and I will say b as int. So I can have something like this. So I can call the function in this fashion. Here is a question. The question is any advantage of parametric group. So as I said, there is no new concept associated with that. The advantages we will come to know when we learn higher order functions and implicit functions. So as of now, what we can imagine is some parameters which behave in a similar fashion, we group them together. Some other parameters which again behave in a similar fashion, we group them together. So that's the idea. The advantages or the use case we'll see once we learn higher order functions. Just hold on to that thought until we come to higher order functions. But other than that, there is no use case as such. There is no use case as such with the parametric group. There is no new concept. But we will see the syntax, how it is helpful. The syntax is a bit helpful. Next we have type parameters. So what is type parameter? So when we say, when I say, if I define a function like this is a value parameter. X is a value parameter, Y is a value parameter, meaning we pass a value for that parameter. We pass 4 as the value for X, 5 as the value for Y. When I define a function, a simple function which takes two parameters and multiplies those two parameters. These parameters are called value parameters because we pass value to them. We pass values to them. 4 is the value to the X parameter and 5 is the value to the Y parameter. In a similar fashion, we can pass type also as a parameter. We can pass integer as a parameter. Like we are passing 4 as a parameter, which is a value. Similarly, I can pass integer as a parameter. So that's what we call as a type parameter. That's what we call as type parameter. So dynamically we will send the data type. We don't predefine the data type. Dynamically we send the data type. To work to work happen, we have to pass the data type in dynamic. My mistake. Type also will be dynamically decided and sent in the flight, and it will be passed in the flight. Let's see how it is required. I mean to say, let me define identity. Let me define a function called identity. It takes a string and it just returns a string. It takes a string and it just returns that. Nothing else. It just returns that. So now the traditional way of calling this function is, I'll just call pass a string here. I'll just pass a string to this parameter. It works fine. Everything is fine. Now if I want to, can I pass 10 here? Can I pass 10 here? So obviously it will give an error. We have defined that function to receive a string and we are passing an integer. Obviously it will give an error saying that required string found integer. In a similar fashion, I cannot pass a double also. It will again throw the same error. Required string found double. Now how can I make my API more generic? So this type parameters usually comes to make your function more generic. Whenever we are developing our library or whenever we are developing a framework, we want our APIs to be more generic. Whenever we expose our API to a third party or some other team, we need to make our API more generic. So this is where the type parameters comes. So I want this function to accept a string I want this function to accept integer. I want my function to accept a double also. I want different data types to be passed as a parameter to this function. How can I do that? That can be achieved with the type parameters. So in that case, I need to redefine my function so that it can accept different types. So I will say here type is of type T. Now I will be passing type also as a parameter, and I will say X is of type T or S or anything. X is of type T, and I will return X. So this is how we define type parameters. Type will be also passed as a parameter here. So when I call this function, when I call this function, I can specify type as int, and I can pass 10 as the value. So it works fine. I can say 10.5 and I specify double as the value, double as the type. Then I pass the string value. Scala is the string value, and the type also I will be specifying as a string. So if you see here, we are passing type also as a parameter. Type is also being passed as a parameter, but the syntax is a bit different. So we have made this API a more generic now. We have made this API more generic so that it can accept any data type. It can accept any data type. So that's what we use the type parameters for solving such problems. So you will see in Scala, lot of type parameters will be used internally. Going forward, we'll be doing the same things. We'll be using all those things. In Scala itself, there are a lot of functions which are generic functions, which are very generic functions. So I hope that was clear. Type parameters. Yeah, there is one thing we wanted to discuss here: methods and operators. Methods and operators are a bit interesting, so it will reveal some few things that we haven't seen yet. So we know that we said val x is equal to 10. We also said that val y is equal to 20, and I also said that Scala is pure object oriented program. So when I said Scala is a pure object oriented program, what I mean is anything that you create in Scala is an object. Anything that we create with val or var is an object. Not just val and var, but anything that we create is an object here. So X is an object of class or type of the type or of the class integer. There is an int class defined, and X is an object of that int class. In a similar fashion, Y is also an object of the integer class. So that's what we mean by a pure object oriented. Anything that we create will be an object. So when anything is an object, when I say Z is equal to X plus Y, what is X? What is plus here? What is plus? When X is an object and Y is also an object, what is plus here? So there is no operators in Scala. There is no operators in Scala. Plus is not an operator. So when we have when we have an object, these are all objects. Any operations inside on the object can be performed only through its methods. If you have an object, any operation you want to do on that object, it can be done through only its methods. So plus is a method here. So there is a symbol. Symbol plus is a method defined inside the integer class. They have defined a plus method. Similarly, inside the integer class there is a minus method. Similarly, there is a star method. Similarly, there is a division method. These symbols are nothing but methods inside the class. So if you recall, we said that expression is a unit of code that returns a value. That makes sense now. So that we are justifying now. So we said that this is an expression, and I said that expression is a unit of code that returns a value, meaning here when we say x plus y, it is actually evaluating the plus method. It is calling the plus method. Internally what happens is, on the x object we are calling plus method and we are passing y as the parameter. That plus method will add the values and it will return an object. Hence we say a expression is a block. Expression is a unit of code that returns a value. So when we say here val x is equal to 10, val y is equal to 20, and I say val z is equal to x plus y. So internally what happens here is we are actually calling the plus method and we are passing y as the parameter to that method. Hence it's an expression that returns a value. Makes sense. Expression is a unit of code that returns a value. That makes sense. So with this what we are having. So I said that I can write either x plus y, or we can write x dot plus y. So these two syntaxes, we can generalize these two syntaxes because they are not restricted to only arithmetic operations. We can apply it on any expression, not just arithmetic operations. So we can generalize this. So we have an object, a space, then the method, then space, then parameter. So we can generalize this syntax in this fashion. Any method or anything any method can be called in this fashion. Similarly, this also, we have an object, dot, then we have method, then we can pass parameter. So either we use this syntax or we use this syntax. You will see both of the syntax being used here and there in Scala. Here and there in Scala. So what I mean by that is, so let's say I have val s is equal to hello Scala. Val s is equal to hello Scala. Then I can say val s1 is equal to s dot, I can call contains method. There is a contains method on a string which will check whether Scala is exist in the S, or whether S contains Scala. Obviously hello Scala contains S Scala, hence it will return true. This is how we write it traditionally, but with the other syntax also we can achieve the same thing. We have an object, we have a method, then we have parameter. I can also write in this fashion. It does not apply only to the arithmetic operation, That syntax apply to anything. We can generalize this with specified object, then space, then method, then space, then parameter. So you will see the code being written in this fashion also, which is nothing but we are calling this method on this object and we are passing this parameter. So I hope this was clear. I hope this was clear. That's what we meant by methods. And so because of that pure object oriented program, anything that we create is an object. Any operation we do is a method call on that object. There are no operators, nothing like that. Hence we call it as a pure object oriented program. We call it as a pure object oriented program. So next we have a bit to till here. Almost we talked about simple things and slightly advanced things. Till here, whatever we talked about is a simples and slightly advanced things. Going forward, it will be more complex things. More advanced things I will be covering, like higher order functions. So we need to go in deep inside the function now. So we need to understand why higher order functions are required. What is the use case of higher order function? First of all, what is higher order function? All those things. So I think this is a new topic and it requires a fresh look from the starting. What we'll do is we'll wind up the session here. We will continue tomorrow on the fresh topic of higher order functions. I hope that should be fine.
Yeah, that's fine. Fine.
Yeah, I hope the sessions were useful and let's wind up the session here. Let's continue tomorrow same time. Any questions or anything that you have, please send me a mail. I will reply to that mail.
So Pramod, one question, so you are saying Scala is pure object-oriented program, and sometimes you are telling it's a functional programming. So can you differentiate?
No, I mean to say it is a combination of that both.
Okay,
It is not like exclusive. It has taken object-oriented programming also and it has taken functional programming also. So it has combined both the things. You can write a for loop, instead of that they have written a map function. You can write a for loop for filtering something, but instead of that they have written a filter function. So you need not use for loop internally, which is implemented using the map function. We usually use that. So we'll come to know once we understand this higher order function, then we'll look into the map function, then we'll see the filter function, then we can differentiate. It will be much more clear in that case. Yeah, we will look in tomorrow. Have a nice day, everybody. See you and take care.
Thanks so much, Prabhat.
Pardon?